This is GATE Computer Science 1999 question. So let's solve it. Relation R is given to you. A, B, C, D, E, F. 6 attributes are there. This is a schema, relation schema. With the following functional dependencies, these functional dependencies are given to you. Which of the following is a key for R? What this key means? Please tell me. What this key means? When you see this word key, this means candidate key. This does not mean super key. This does not mean primary key. Remember, key means candidate key. I told you this is given in the Ullmann book, right? Yes or no? Okay, most of the authors, majority of the authors, remember, like Ullmann, Korth, okay, most of the authors, they assume that key means candidate key. That key means candidate key. Okay, most of the authors, they assume that key means candidate key. Okay, so remember, key does not mean super key does not mean primary key means candidate key. So here the question is asking which of the following is a candidate key. So how to solve this question? Tell me. So you can eliminate the options. What you can do, you can eliminate the options. First you check, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Let's check. Which attribute does not appear on the RHS? Tell me. Which attribute is not appearing on the RHS? You can see A appears, A is appearing, B is appearing, D is appearing, F is appearing. A, B, D, F. These are appearing. So C does not appear, right? So I can say that C, E, they are not on RHS. They are not on RHS of any FD. Correct? They are not on RHS of any FD. So what should happen? So C must be part of every candidate key. So this C must be part of every candidate key. Correct? Yes or no? This C must be part of every candidate key. Now you tell me, this C, is it enough? This C itself, is it enough? This C, this itself is enough or not? Let's check what is the closure of CE. That will be CE. What else you can bring? This CE. Remember, C can determine F. This CE, this can determine F. So you will get F also. This E can determine A. Yes or no? You can see this E can determine A. So you got A also. What else? So you can see this A can determine B. This A can determine B. So you got B also. What else? EC can bring D. EC can bring D, right? Notice this. Look at this. EC. This EC can bring D. This can bring D. So you got the entire relation R. Closure of EC. That is your entire relation R. So remember, this must be part of every candidate key. This CE must be part of every candidate key, and this itself is enough. Yes or no? CE must be part of every candidate key, and this CE itself is enough. So tell me, no other candidate key possible? Yes or no? Correct? So you can see C plus that is your entire relation R. So no other candidate key possible. So no other candidate key possible. No other candidate key is possible. Okay. There is no other candidate key possible. So answer will be what? The answer will be option B. How can you eliminate the options? You don't have to solve the question. You can eliminate the options. How can you eliminate the options? You can notice CE must be part of every candidate key. Yes or no? So CE must be part of every candidate key. So automatically these options are gone. These options are gone. Only this will be the remaining options. So this will be correct. Because CE must be part of every candidate key. This CE must belong to every candidate key. Okay, this must belong to every candidate key. So that is the reason I can say option A, C, D. These are gone. So automatically answer will be option B. Let's move on now. Tell me the answer for this question. This is GATE 2005 question. Consider relation schema R, A, B, C, D, E, H on which the following functional dependencies are given. Set of functional dependencies given to you. What are the candidate keys of R? So first you tell me, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Tell me. So you can see this A, C, D, A, C, D, B, they are appearing on the RHS. A, C, D, B, they are appearing on the RHS. E, H do not appear on the RHS. Yes or no? So you can notice that E, H, these two attributes, these are not on RHS. These are not on RHS of any FD. of any FD. They are not on RHS of any FD. So what should happen? So they must belong to every candidate key. So this EH must be part of every candidate key. Correct? They must be part of every candidate key, right? Okay, very simple. So now tell me, are they enough? This EH, are they enough? First you check, because they must be part of every candidate key. Whatever candidate key you take, this EH must be part of every candidate key. Okay, so first you tell me, this EH, is it enough? Let's check what is the closure of EH. So EH can bring what? EH can bring EH. Anything else? No. Okay, yes, E can bring C also. E can bring C also. So you got EHC. What else? So this is the closure of EH. Correct? So I can say this EH is not a super key, right? This EH, this is not a super key, because EH cannot determine everything. EH cannot determine everything. So what we need to do? Remember, EH must be part of every candidate key. So now what you do? Now you add one more attribute. With this EH, you add one attribute and you check. Okay, let's add one attribute and check. So with this EH, let me add A and let me check. Let me check what the closure. If I give this power, this EH, remember EH can determine EHC. Okay, so what you got? This EH can determine EHC. So these are these four attributes you got. What these four attributes can bring? These four attributes, what they can determine? These four. You can see A can determine B. Yes or no? This A, this can determine B. So you got B also. What else? Tell me. You can see BC can determine D. Correct? This BC, you can see this will determine D. So you got D also. Okay. So did we got all the attributes? Yes, we got all the attributes, right? So we got the entire relation R. Okay. So what this means? This is a super key. This means this is a super key. And because this is minimal, remember this AEH, this is super key. And since it is minimal, since this AEH is minimal, so I can say this is candidate key. Yes or no? Because this is minimal, so what I can say? So I can say this is a candidate key. ECH, this is a candidate key. Okay? So you got your one candidate key, you got this AEH. Okay? So you got AEH. Now tell me, what else? Let me know. What else? First of all, you tell me one thing. Some options you can eliminate, right? Some options you can eliminate because this EH must be part of every candidate key. EH, you can see this EH must be part of every candidate key. So some options you can eliminate. What are the options you can eliminate? EH must be part of every candidate key. So some options are gone. Which options are gone? This option is gone. This option is gone. These options are definitely gone because EH must be part of every candidate key. Okay, this is already very simple that this EH, this must be part of every candidate key. This must be part of every candidate key. Every candidate key. Okay, so this must be part of every candidate key, this EH. So automatically which options are gone? So actually this option is also gone, right? This option is also gone. Option C is also gone. So answer will be option D. Only option D is remaining. Yes or no? Only option D remaining because EH must be part of every candidate key. So option C is also gone. So only option D is remaining. Actually, you don't have to solve this question. The answer will be option D. Yes or no? You don't have to solve the question. You can easily see that answer will be option D. But in the question, if they ask you, how many candidate keys are there? Then what you need to do? In the question, if I ask, how many candidate keys are there? In the GATE exam, you don't have to solve this question. You can directly say answer is option D because you can eliminate ABC. These options you can eliminate. But in the GATE exam, if they ask you how many candidate keys are there, then you have to compute. Yes or no? Then you have to calculate. Now you have to solve the complete question. So tell me, we have already found that this AEH. Okay, so this AEH, this we found candidate key. What else? What else we need to check? Okay, let me check this BEH. What the closure of BEH? Tell me. The closure of BEH, that will be BEH. And this E can bring C. This E can bring C. What else? Tell me, what else? Let me know. So you can see BC can bring D. This BC, it can bring D. So you got D also. Now D can bring E, D can bring A. This D can bring A. Yes or no? So you got everything. You got A, B, C, D, E, H. So you got everything. Okay, you got everything. So this is super key. Okay, so what I can say? So I can say this is super key. Correct? This is super key. And because this is minimal, and since this is minimal, this BEH is minimal super key. Because this is minimal super key. So what I can say? So what I can say? So this is candidate key. So this BEH, this is a candidate key. Yes or no? So you got this another candidate key. What else? Tell me. What else we have to check? So AEH we got. This is a candidate key. BEH we got. This is a candidate key. Now we have to check CEH. Okay, let's check CEH. What about this? Is this a candidate key? This is CEH. Tell me. Will it bring everything? See, this can bring CEH only. Nothing else, right? Okay, you can get nothing else. Nothing else you can get. So definitely this is not even a super key. Yes or no? So this is not a super key. Not even a super key. This is not even a super key. Okay, now you tell me. So now you have to check DEH. This DEH you have to check. What is the closure of DEH? DH will give you what? This will give you DEH. Remember, D will give you A. D will give you A. Okay, this D can give you A. Now you can stop, right? Now this itself can give you everything. Yes or no? This AEH, this itself can give you everything. This itself can give you everything. This AEH, this will give you everything. Okay, this will give you B, this will give you C, everything. So you can stop. Okay, so finally, this is your answer. Now tell me, do you have to check 4 attributes? Combination of 4 attributes, will you check? Will you check combination of 4 attributes? Tell me. Let me know. See, so far we got these candidate keys. AEH, this is a candidate key. BEH, this is a candidate key. DEH, this is a candidate key. Now you tell me, do you have to check combination of 4 attributes? 4 attributes. 4 attributes combination. Let me check. Okay. Will you check 4 attribute combinations? 4 attributes combo. Okay, 4 attributes. But 2 of them are already fixed. Yes or no? 2 of them are already fixed. What are those? 4 attribute combo you are checking, but 2 are already fixed. EH must be part of every candidate key. EH, these are fixed. Now you tell me. Now you tell me. If you do this, what 2 attributes you will take? Which 2 attributes you will take? See, you must make sure that you don't get superset of these. Okay. See, whatever 2 attributes you take, this will become superset of candidate key. This will become superset of candidate key. Yes or no? Is this clear? Whatever 2 attributes you take, whatever 2 attributes you take, this will become superset of candidate key. Proper superset of candidate key. Okay. If you take 2 attributes, then this will become proper superset of candidate key. So what I can say? I can say, so this is not a candidate key. Yes or no? This is not a candidate key. Is this clear? Please tell me. Okay. So you don't have to check 4 attribute combinations. So your answer will be what? How many candidate keys are there? If they ask you how many candidate keys, the answer will be 3. Okay. This will be your answer. So let's move on now. Let's solve this question. So this is GATE Computer Science 2014 question. Let's solve it. Consider relation schema R. These are the attributes. So many attributes are given to you. The set of functional dependencies. These are the functional dependencies that are given to you. The question is asking, what is a key? What key means? Tell me. What is the key? Key means candidate key. Okay, key means candidate key. Most of the authors, remember I told you, most of the authors like Ullman, NPTEL. Okay, so most of the authors, they assume that by default key means candidate key. Okay, by default, this word key, this means candidate key. Okay, so remember the question is asking for candidate key. Now, these functional dependencies are given to you. Okay, these functional dependencies. Do you remember I told you what this functional dependency actually means? What is the another notation for this? There is another notation, simple notation. What is the simple notation for this? Please tell me. What is the simple notation for this FD? The simple notation is L determining N. Yes or no? This is the simple notation. For example, what is the simple notation for this? What is the simple notation for this FD? For this FD, what is the simple notation? Tell me. For this FD, what is the simple notation? The simple notation is EF determining G. This is the simple notation, right? Yes or no? Is this clear? We have already seen this. Okay, for example, look at this. Look at this functional dependency. For this functional dependency, what is the simple notation? This is your EH determining KL. Okay, very simple, right? Yes or no? So this is the idea. Now let's solve this question. So functional dependencies are given to you. Is there any attribute which does not appear on RHS? See, these many attributes are given to you: EF, GH, I, J, K, L, MN. Now tell me, is there any attribute which does not appear on RHS? So you can see this N is appearing on RHS. This is appearing. Okay, this appears on RHS. This appears. M appears on RHS. This appears. Next, KL appears on RHS. KL, they appear on RHS. Next, IJ appear on RHS. IJ. Next, G appears on RHS. Okay, so you can see that E, F, H, they do not appear on RHS, right? So you can notice this E, F, H, these attributes, they are not on RHS. They are not on RHS of any functional dependency. Yes, correct. These attributes, E, F, H, they are not on RHS of any functional dependency. So who can determine them? They are not on RHS of any functional dependency. So who can determine them? Only they can determine themselves. Yes or no? Okay, these people, these three people, they are not on RHS of any functional dependency. So only these people can determine themselves. EFH, they can determine themselves. Only they can determine themselves. Okay, so I can say that they must be part of every candidate key. This EFH, okay, they must be part of every candidate key. They must be part of every candidate key. They must be part of every candidate key. Now, can you eliminate the options? Remember, they must be part of every candidate key. Whatever candidate key you create, they must be part of every candidate key. Now, can you eliminate the options? So now you can easily eliminate the options. So I can say this is not correct. This is not correct. Okay, now two options are remaining. Yes or no? Two options are still remaining. Okay, option A, option D are gone because EFH must be part of every candidate key. Now still two options are remaining. So let me check what they can bring. Are they enough? EFH, are they enough? Tell me. Are they enough? Let me know. So what they can determine? EFH, they can determine E, they can determine F, they can determine H. What else? EFH. EF can give you G also. Yes or no? Notice EF can give you G also. This EF, they can give you G also. What else? What else? Tell me. EF can give you G also. F can give you IJ. F can give you IJ. Look at F. F can give you IJ. Okay. Now these people, what they can give you? EF, GH, IJ. So you can see EH can give you KL. Okay. Yes or no? EH. Look at this EH. This EH. This can give you KL. This can give you KL. What else? Now you got KL. Remember, K can give you M. This K can give you M. So you got M also. Remember, this L can give you N. This L can give you what? This L can give you. This L can give you N. So you got N also. Did we get everything? Please tell me. Did we get everything? Let me know. Just look at this and tell me. Yes, we got everything. We got everything, right? So you can see that we got everything. Okay, this is your equal to R. We got everything. I can say EFH. This can determine all the attributes. This can determine entire relation R. So that is the reason. What I can say. So this itself is enough. This must be part of every candidate key. This EFH. This must be part of every candidate key. And this itself is enough. So this is the candidate key. And this option C, this is not a candidate key. This is a super key. Yes or no? Okay, option C, that is a super key. So remember this option C, if you look at. If you look at option C, that is a super key. That is a super key, not a key. Not a key. Remember, key means candidate key. I told you, when you see this word key, this means candidate key. Okay, by default, this word key, this means candidate key. Okay, so whenever you see this word key, this means candidate key. So here, the answer will be option B. Answer will not be option C, because option C, that is not candidate key. Okay, that is super key, but that is not candidate key. So your answer will be option B. Did you understand? Please tell me. Did you understand this question? Let me know. So can I give you this question as a homework? You have to find candidate keys for this, and for this. Okay, 3 relations are given to you. For these relations, you have to find the candidate keys. So discuss these questions in the group. Okay, in the Go Classes private Telegram group, you can discuss all these questions. Okay, make sure that you are comfortable with finding candidate keys, because this is important. In the GATE exam, many questions are there. Let's solve this question. This is GATE Computer Science 2002 question. From the following instance, this instance is given to you of relation schema R ABC. We can conclude that which functional dependencies are there. We can conclude which functional dependencies are present. First, you tell me, the question is asking which functional dependencies are present. You tell me, is it asking that within this instance which functional dependencies are present? Tell me, the question, is it asking which functional dependencies are present in this instance? No, this is not asking. See, please understand the difference between this question and the difference between this question. This is your GATE 2000 question. This is GATE Computer Science 2000 question. In this question also instance is given. This instance is given. But the question is asking which functional dependencies are satisfied by the instance. Okay, which functional dependencies are satisfied by the instance. Is this clear? In this question, you can see in this GATE 2000, in this question, the question is asking by the instance. This instance will satisfy what? Okay, is this clear? This instance will satisfy which FD? Okay, so the question is asking only for instance. Only for instance. The question is asking only for instance, means this instance will satisfy which FD? Okay, now you come back to this question. Now you come back to this GATE 2002 question. Now, can you notice in this question, instance is given to you. See, instance is given to you, but the question is not asking for this instance what will happen. Yes or no? See, this instance is given to you, but from this instance, you can eliminate some functional dependencies. I told you that if some instance is given to you, if I give you some instance, then some functional dependencies you can eliminate, but you can never confirm that some functional dependency holds. Yes or no? Do you agree with me? I told you that if I give you some instance, okay, now you can eliminate some functional dependencies from the instance. If I give you this instance, then some functional dependencies you can eliminate, but you can never say that some functional dependency holds. Is this clear? Because functional dependencies, these are defined on what? On the instance or on the schema? Tell me. Functional dependency, they are defined on the instance or they are defined on the schema? They are defined on the schema. You already know. Functional dependencies or any integrity constant, whatever integrity constant you take. Yes or no? Functional dependencies or any integrity constant, they are defined over what? They are defined over schema. They are defined over schema, not over instance. Not over instance. Is this clear? Please tell me. Okay, not over instance. So remember, functional dependencies, these are defined over schema. Did you understand the difference between this question and this question? Please tell me. See, in this question, I am asking which functional dependencies are satisfied by the instance. Means by this instance, which functional dependencies are satisfied. Okay, but now come back to this question. In this question, instance is given to you, but I am not asking you by this instance which functional dependency will be satisfied. Did you understand? Please tell me. Don't keep any confusion. Don't keep any confusion. Okay, in this question, you can notice we are not asking that by this instance, what is satisfied. By this instance, what will be satisfied? That is, we are not asking. We are not asking that. Okay. And I told you that if I give you some instance, then from that instance, you can eliminate some functional dependency. Some functional dependency you can eliminate, but you can never say that some functional dependency will hold, because functional dependencies, these are defined over schema. They are not defined over instance. Okay, is this clear? So now tell me, from this instance, you can only eliminate, you can never say that a functional dependency holds. Yes or no? So remember, you can never say option A, you can never say option B, because you can never say, you can never say that some functional dependency will hold. Is this clear? Please tell me. Let me know. So if I give you some instance, then you can find some functional dependency, you can find which does not hold on the schema, So from the instance, you can eliminate some functional dependency, but you can never say that some functional dependency will hold. So option A, option B, these are gone. Now tell me, what is option C? B does not determine C. Can I say this from the instance? B does not determine C. Yes, you can notice B does not determine C. In these two rows, B value is same, but C value is different. Yes or no? Look at these two tuples. In these tuples, B value is same, but C value is different. B value is same, C value is different. So I can say B does not determine C. Okay, yes or no? So definitely on the schema also, this FD will not hold. Yes or no? On the schema, this FD will not hold. Tell me one thing. When can you say that FD will hold on the schema? Tell me. When can I say that some functional dependency will hold on the schema? On the schema, some functional dependency will hold. When can I say? When every instance will satisfy it. Yes or no? When every legal instance will satisfy that FD. Yes or no? Very simple. So remember, some functional dependency will hold on the schema if every legal instance will satisfy that functional dependency. You can see this instance does not satisfy this functional dependency. This instance does not satisfy this functional dependency. So what I can say? So I can say this functional dependency does not hold on the schema. Okay, this functional dependency does not hold on the schema. So I can say F does not determine C. Yeah, that is correct. That is correct. What about the remaining? What about option D? A does not determine B. Can you say this from the instance? From the instance, can you say that A does not determine B? From this instance, can you say that A does not determine B? No. Okay, from this instance, we cannot say A determines B or not. Yes or no? We cannot say. We cannot say A determines B or A does not determine B. Yes or no? Okay, we cannot say. We cannot say A determines B or A does not determine B. So this is what we cannot say. So this is gone. So answer will be option C. Is this clear? Please tell me. So please understand the difference between this question, this gate exam, this question and this question. Please understand the difference. In this question, instance is given to you and we are asking which functional dependency will hold by the instance. Okay, which functional dependency are satisfied by this instance. Okay, so this is the difference between these two questions. Understood? So for this question, the answer will be option C. Let's move on now. This is GATE Computer Science 2000 question. Consider the following relational instance. This instance is given to you. This instance is given to you. The question is asking which of the following functional dependencies are satisfied by the instance. The question is asking for the instance or for the schema. Please tell me. This question, is it asking for instance or for the schema? This is asking for the instance. The question is asking which functional dependencies are satisfied by the instance. By the instance. Yes or no? Which functional dependencies are satisfied by the instance? By this instance, which functional dependencies are satisfied? So now tell me the answer. Now tell me the answer. Let's check one by one. xy determining z. What about this one? xy determining z. What about that? xy, does it determine z? If you have same value for xy in two tuples, then can I say you have same value for z in those tuples? Means whenever two tuples have same xy combination, then can I say those tuples have same z value? Tell me. You can easily see that no tuples have same xy combination. So that is fine. Yes or no? If I give you the value of xy, can you tell me the value of z? Can you determine the value of z? See, if I give you the value of xy, this combination if I give you, then can you determine the value of z? Tell me. If I tell you the combination, this xy combination value, if I tell you, then can you determine z? Can you determine z? Tell me. For example, if I tell you xy is, for example, if I tell you xy is 1, 4, then what will be z? What will be z? If I tell you xy is 1, 4, then z will be 2. If I tell you xy is 1, 5, then z will be 3. If I tell you xy is 1, 6, z will be 3. If I tell you xy is 3, 2, then z will be 2. So can you notice xy determines z? Do you agree? Xy determines z. So yes, this will hold. Yes or no? For this instance, by this instance, remember, by this instance, xy determining z holds. Okay, so this will hold. What about the next one? What about z determining y? What about z determines y? Will it hold? Z determines y. Will it hold? You can see in these two tuples, look at the first tuple and last tuple. In these two tuples, look at this tuple and this tuple. Here you can notice the z value is same, but the y value, that is different. Yes or no? Y value is different. Okay. So if I tell you the value of z, can you determine the value of y? If I tell you the value of z, now can you determine the value of y? Please tell me. Let me know. If I give you the value of z, now can you determine value of y? We cannot determine. We cannot determine. Yes or no? Okay. Yes or no? We cannot determine. So remember, by this instance, I can say by this instance, what I can say by this instance, I can say this does not hold. Okay. Not satisfied. Not satisfied. Okay. This instance will not satisfy this. Okay. What about the remaining? So you can see option A, that is gone. Option A is gone. What about y determining z? What about y determining z? Can I say y will determine z? Yes, y will determine z, right? Yes or no? You can see y will determine z. Notice that y value does not repeat. Okay, so automatically this will determine z. Y value does not repeat. Because y value does not repeat, so y will determine z also. Y will determine x also, because y value does not repeat. So you cannot create a violation. You cannot create a violation. Tell me one thing. How to create violation of A determining B? What you need? If you want to create a violation of A determining B, then what you need? What you need if you want to create a violation of A determining B? Then definitely you need this type of situation. See, this type of situation you need that two tuples have same A value, but they have different B value. Yes or no? Is this clear? Please tell me. So if you want to create a violation of A determines B, you must have this type of situation. You must have this type of situation. Is this clear? You must have this type of situation that if in two tuples you have same A value, but you have different B value. Okay, this type of situation must be there. If this type of situation is there, then violation. Okay, that implies violation of A implies B. Okay, is this clear? That implies violation of A implies B. This is the situation for violation of A implies B. Now you can notice, because Y value does not repeat, so is violation possible? Look at Y value. This Y value does not repeat. Notice, this Y value does not repeat. So can violation exist? Can you create violation for Y determining Z, Y determining X? You cannot create. Yes or no? So very simple. Y determines Z, Y determines X. Okay. What about YZ determining X? What about YZ determining X? Again, this value does not repeat. You can easily see this YZ combination never repeats because Y does not repeat. See, notice Y does not repeat. This Y value does not repeat. So this combination also does not repeat. Because this combination does not repeat, so you cannot create a violation for this functional dependency. For this functional dependency, you cannot create a violation. So I can say this also will hold. So can I say option B, that will hold, yes or no? Option B is correct. Option B, that is correct. Is this clear? Okay. So remember this point, this simple point, you understand that Y value does not repeat. So you cannot create violation for Y determining Z. Similarly, Y value does not repeat. So you cannot create violation for this functional dependency. Now remember, Y value does not repeat. So this combination also does not repeat. Now remember, if this combination does not repeat, then you cannot create violation for this functional dependency. Okay, so very simple. For this question, I can say answer will be option B. What about option C? What about option C? In option C, this X does not determine Z. Let's check. Can I say X determines Z? Can I say X determines Z? No, you can notice X does not determine Z. Yes or no? X does not determine Z. So option C is also wrong. What about Y determining X? That will hold. Y determining X will hold. But what about XZ determining Y? What about XZ determining Y? Please tell me. What about XZ determining Y? Can I say XZ determines Y? No, because you can easily see XZ13, XZ13. Yes or no? Look at these two tuples. Look at these two tuples. XZ is 13. But what is the value of Y? So you can see in these two tuples, XZ combination is same, but Y value is different. Okay, so what I can say, this is also not correct. So what is the final answer? The final answer is option B. Is this clear? The final answer is option B. Let's solve this question. This is GATE 2014 question. Given an instance of student relation. This student relation is given to you, instance is given to you. Okay, for a student relation, this instance, this data is given to you. For student name, student age, this combination, student name, student age, this combination. Okay, for this to be a key, we want this to be a key. Then what should be the value X should not be equal to? What should not be the value of X? Remember, we want this to be a key. Tell me one thing. If this is a key in any table, like for example, if you have this A, B, C, D, let's assume you have this table you have. In this table, if I tell you that AB is a key, then what that means? If I tell you that AB, this is a key, whatever key, candidate key or super key, whatever key you take. Okay. If I tell you that AB, this combination is a key. Okay. Whatever you take, candidate key, super key, but by default key means candidate key. Okay. Remember, I told you that by default, please understand, by default key means candidate key. By default key means candidate key. But in this question, it does not matter. In this question, it does not matter. Yes or no? In this question, even if you take it primary key, or you take it super key, or you take it candidate key, in this question, it will not matter. Okay. But remember, by default, key means candidate key. By default, this word key, this means candidate key. Okay. But in this question, it does not matter. You can assume primary key, you can assume candidate key, you can assume super key. In this question, it does not matter. So you can see, if AB is a key, then what will happen? AB is a key, then what will happen? Then no two tuples can have same AB value. Yes or no? Then in any instance, whatever instance you take, then in any instance, okay, whatever instance you take, remember, then in any instance, this AB combination, okay, in any instance, this AB combination cannot repeat. Yes or no? Correct? I can say in any instance, this AB combination cannot repeat. This AB combination cannot repeat. Whatever instance you take, this AB combination cannot repeat. So for every two tuples, this AB combination will be different. Okay, for every two tuples, AB combination will be different because this cannot repeat. So now you tell me, if you want this combination to be a candidate key, if you want this combination to be a key, then you can see that no two rows can have same value for these two attributes. Yes or no? For this combination, no two rows have can have same value, or I can say this cannot repeat. Okay, so finally your answer will be what? You can see here, you can note that Sankar comma 19 is already there. See, Sankar comma 19 is already there. This value is already there for this combination. Sankar comma 19 is already there. So this Sankar comma 19 cannot appear again. Yes or no? Sankar comma 19 is already there. So this Sankar comma 19 cannot come again. Cannot come again. So this x cannot be 19. Okay, so x should not be equal to 19. The answer will be 19. Okay, everything else is fine. Everything else is fine. This x can be 17, 18. Everything else is fine. Okay, this x can be 0, x can be 1. Everything else is fine. But x cannot be 19. If you want this combination to be a key, so answer will be 19. Let's move on. Can you solve this question? Okay, let me give you this question as a homework. Here you can notice E is a key. Key means candidate key. Okay, key means candidate key. The question is asking what are the maximum number of super keys? This is a very simple question. Answer will be what? Answer will be 8. Yes or no? Answer will be 8. Okay, let's move on. This question also you can try. Okay, just try this question yourself. In this question, the question is saying that this is GATE 1994 question. An instance of relation scheme has instance, remember, instance has distinct value for A. Then can you conclude that A is candidate key? No. From the instance, we cannot conclude, right? From the instance, we cannot conclude. Yes or no? Very simple. This is GATE Computer Science 2006 question. The following functional dependencies are given to you. Which one of these options is false? Some options are given to you. The question is asking which option is false. The question is asking closure. Yes or no? The question is asking what is the closure of set of attributes. So tell me which option is false. Let's start. Let's do it one by one. So what is CF closure? What is a CF closure? See, remember, this is the symbol for closure. But I told you some people, some authors, they use star also, no problem. Okay, you can understand that this is closure. So tell me what is CF closure? What they will bring? CF. See, CF will bring CF by reflexivity. CF can bring CF by reflexivity. Yes or no? Because of reflexivity, because of trivial functional dependency, CF brings CF. This is your reflexive law. Okay, this is your reflexivity. So you can start with CF. Now, what these CF can bring? These two people together, what they can bring? Remember, C itself can bring G. This C, this itself can bring G. So you got G also. You got G also. Now, these three people, what they can bring? These three people, what they can bring? See, this F can bring E. This F can bring E. So you got E also. Okay. Remember, this G can bring A. This G can bring A. So you got A also. Now, these five people, what they can bring? Can they bring B? Can they bring B? Can they bring B? No one can bring B. Only B can bring B. Yes or no? See, on the RHS, you don't have B. Notice. On the RHS, you don't have B. So can I say only B can bring B? Can I say only B can determine B? Agree with me? Because on the RHS, you don't have B. Only B can determine B. Is there anything else we can determine? Yes. This AF can determine D. Yes or no? This AF. See, these two people together. Look at these two people. These two people, AF, they can determine D also. So you got D also. Everything you got, B you cannot get. So that's it. See, B, only B can determine B. Only B can determine B. Everything else you got. So that's it. This is your answer. So tell me, this statement, the statement option A is true or false? Option A is actually true. The question is asking false. Okay. Now tell me, what about option B? What is the closure of BG? What is the closure of BG? What they can determine? See, BG can determine BG. Okay. BG can determine BG by reflexive property, by transitive, by trivial FD. This is your trivial FD that BG can determine BG. What else? See, G can determine B. G can determine A. This G can determine A. We can, okay, so you got A also. Now tell me, now remember this AB. AB can determine CD. A, B, these two people, they can bring CD. They can bring CD. What else? Now you got this family. These 5 people, what they can bring? What they can bring? See, C can determine G. Okay, you already got G. What else you can bring? Can you bring something else? Tell me. Let's see. Can you bring something else? You cannot use this. C determining G, that is already over. You cannot use this. D determining F, but we don't have E. So that's it. Yes or no? Nothing else. That's it. So you cannot bring anything else. So that's it. So finally I can say, what about this statement? Is this true or false? This statement is actually true, but the question is asking false. Tell me the next one. What about option C? What is the closure of AF? What is AF closure? Tell me. AF can bring AF. AF can bring AF. What else? See, AF can bring D also. AF can bring D also. What else? What else? You got AFD. F can bring E also. F can bring E also. So you got AFDE. Now D can bring F. Okay, D can bring F, but that is already there. That is already there. What else? Can I use this? I cannot use this because I don't have AB. I cannot use this because I don't have G. F can determine E, that I already used. C can determine G, but I don't have C. Okay. So that's it, right? Yes or no? So you cannot do anything else. You cannot do anything else. So this statement is actually false. The question is asking false. So option C will be correct. What about option D? Please tell me. What about option D? What is the closure of AB? Let me know. The closure of AB, what that will be. See, you can see AB can bring ABCD. AB can bring ABCD. These 4 people you got. Okay, very simple. Now, what else? C can bring G. C can bring G. You got G also. Okay, now you have ABCDG. G can bring A, but A already have. We already have A. Okay, what else? Tell me what else? What else? Can we bring something else? See, I cannot use this because I don't have F. I cannot use this because I don't have E. I cannot use this because I don't have F. So that's it. Yes or no? Is this clear? See what I'm saying. Just notice. These 5 people I have. Now notice. I cannot use this because I don't have F. I don't have F, so I cannot use this. I don't have E, so I cannot use this. I don't have F, so I cannot use this. Yes or no? This I have already used. This I have already used. This I have already used. So that's it. So finally, what about this statement? This statement is actually true. So the question is asking what are false statement? The answer will be option C. Now let's solve this question. This is GATE IT 2005 question. In a schema with attributes A, B, C, D, E, the following set of functional dependencies are given to you. This is the set of functional dependency. Which of the following functional dependency is not implied by the above set? These functional dependency are given to you. The question is asking which of the following functional dependency is not implied by the above set? This is your set of functional dependencies. Let's call it S. So which of the following functional dependency is not implied by this S? So what you will do? For each option, what you will do? Please tell me. Let's check option A. For option A, what you will do? So very simple. See, what you want to find out? You want to find out that this functional dependency, can you infer from S? This is what we want to find out. Yes or no? This is what we want to find out, that from this given set of functional dependency, can you infer this FD? Okay, can you infer this FD? So what is the best way? What is the best way? The best way is in this S, you find what the CD closure. In this S, you find what CD can determine. Yes or no? In this S, find what CD can determine. Find what this CD can determine. Okay, what this CD can determine means you find what is the CD closure. Can CD determine AC? Can CD determine AC? Okay, our target is AC. Can you get AC? So tell me, what is the CD closure? Very simple. CD can determine CD by reflexivity. Okay, trivial functional dependency. CD can determine CD. What else? CD can determine E also. So CD can determine E also. What else? E can determine A also, so you can determine A also. What else? A can determine B also, so you got B also. Anything else? You can see A can determine C also, you got C already. Okay, what else? B can determine D, that you already have. Okay, that you already have. So anyway, is this cover? Yes, this is the closure of CD. This is the closure of CD. This is the closure of CD. Now you can notice, you can easily see CD can determine AC. That's it. See, look at this. CD is determining AC, right? CD is determining AC. Okay, so here you can easily see that CD closure contains AC. Okay, CD closure contains AC. What it means? It means CD determines AC. Okay, correct. So I can say this can be inferred. Yes or no? Option A can be inferred. But the question is asking not inferred. The question is asking not implied. This is what the question is asking, which is not implied. But actually, this is implied. This option A, I can say this is actually implied. This is actually implied by S. This FD is implied by S. Let's see option B. What about option B? For option B, what you will do? Now you will find closure of BD, right? Yes or no? You will find what the closure of BD means. What BD can determine? This BD. What this BD can determine? See, BD can determine BD by reflexive property. This is your reflexivity. So BD can determine BD. What else? What else? You can see B can determine D, that we already have. Okay, so B can determine D, that we already have. What else? Tell me. This BD. What else BD can determine? Let me know. What else BD can determine? Nothing else. Yes or no? BD can only determine BD, nothing else. So I can say that BD cannot determine C. Yes or no? So I can say this FD, this is your answer. Okay, because this is not implied by S. You can see this is not implied by S. What is the reason? You can see that BD cannot determine C. You can easily notice BD cannot determine C. BD cannot determine C. Okay, so I can say that BD cannot determine CD. BD cannot determine CD. So I can say this option B, this is not implied by S. And the question is asking not implied. So the answer will be option B. Now let's see the option C. What about option C? Please tell me. What about option C? You want to check this FD is inferred by S or not. Means from this S, can you get this FD? Okay, so tell me what you will do. Very simple. In this S, you will find what is the BC closure. In this S, you will find what BC can determine. What BC can determine? See, BC can determine BC because of reflexive property, reflexivity. Okay. Now, what BC can determine? B can determine D. So you got D also. Now you can stop. Do you agree with me? See, you can stop because you can see BC can determine D. You can easily notice that BC can determine D. You can easily notice BC can determine CD. Yes or no? So I can say this option C, this is actually implied. This is actually implied by S. Okay. But anyway, tell me what is the BC closure? Tell me the complete BC closure. Anyway, tell me the BC closure, complete BC closure for practice. So you can see BC, we got BCD. Now CD can give you E also. So CD can give you E also. E can give you A also. So you can get A also. What else? What else? Please tell me. So yes, we got everything, right? We got everything. Okay. So very simple. So I can say this option C, this is actually implied by S. The question is asking not implied. So the answer will be option B. What about option D? Please tell me. What about option D? Let me know. In this option D, what you will do? You will find AC closure. Basically, you will check in this set of functional dependency, what AC can determine. What AC can determine, this AC, what it can determine. So AC can determine AC. You can see A can determine B. Can you stop here? Can you stop here? Please tell me. Can you stop here? Yes, you can stop here. You can stop here because AC can determine BC. Okay, AC can determine BC. But anyway, tell me the complete closure. Tell me the complete closure. This AC closure. Tell me the complete closure. You can see A can determine C. We already have C. Next, ACB. B can determine D. So you got D also. Next, CD can determine E. So you got E also. So you got everything. Okay. So anyway, I can say this is also implied. So tell me finally answer is what? So remember, this is also implied by this option. This option is also implied by S. So anyway, the question is asking not implied. So what is not implied? Tell me. The question is asking what is not implied. So the answer will be option B. This is your answer. Okay. Very simple question.